The vacuum advance diaphragm is linked directly to the breaker plate. Vacuum acting on the diaphragm rotates the breaker plate against the direction of cam rotation. This causes the breaker points to open sooner, so the spark is advanced. For example, on a level road under part throttle cruising conditions, vacuum is high, and this advances the spark for maximum efficiency and economy. And remember, this is in addition to the centrifugal advance provided at cruising speed. If the throttle is suddenly opened wide, vacuum decreases, and the spring-loaded diaphragm quickly moves the breaker plate back toward its original position. This is desirable because at open throttle the mixture is more highly compressed, burns faster, so less spark advance is needed. To eliminate vacuum advance at idle, the vacuum source for the advance unit is a port located in the carburetor throttle bore just above the throttle plate when it's closed.
And that suggests a warning. If engine idle is higher than specified, the vacuum advance port will be partially uncovered, and you'll get some unwanted spark advance at idle. To make matters worse, higher than specified idle speed also causes some unwanted centrifugal advance. So if carburetor idle mixture and speed aren't right, ignition at closed throttle will be advanced, and the engine will tend to race when the throttle is released. Any other tips, Bob?
Just a couple, Tech. If the diaphragm in the vacuum advance unit is punctured, both economy and performance will suffer. To test the diaphragm, apply vacuum to the advance unit. I find the easiest check is to apply mouth suction to the inlet and see if the diaphragm moves the breaker plate and holds without leaking. Be mighty careful how you go about disconnecting or connecting the vacuum advance line to the vacuum advance unit. A careless yank or push can spring things enough to affect the calibration of the vacuum advance unit. Before checking or adjusting basic timing, remove the vacuum line from the vacuum advance unit and plug the end of the line. Disconnecting the vacuum line is the surest way of making sure unwanted vacuum advance doesn't give you a false basic timing indication. After setting basic timing, I speed up the engine and watch to make sure the timing advances as speed increases. This doesn't take the place of bench testing the distributor, but it does assure me that the centrifugal advance is working. Next, let the engine idle. Reconnect the vacuum line and watch the timing marks. There should be no timing change. If the timing advances, I recheck carburetor mixture and idle adjustment to find out why vacuum advance is coming in at idle.
On today's engines, it's very important to set timing exactly to specifications. A few years ago, most engines would tolerate a certain amount of fudging to compensate for fuel octane and other variables. On current models, use the recommended fuel grade and set the timing right on the specified button.
Here's something that's sometimes overlooked. Because point gap and dwell affects timing as well as secondary voltage, timing must be rechecked whenever point gap is adjusted or changed. If contact point gap is too wide, the points open sooner, so ignition timing is advanced. Besides, dwell and secondary voltage are decreased, causing a miss at higher speeds. On the other hand, a narrow point gap causes point bounce and results in rough engine operation at lower speeds and missing at higher speeds. Play it safe. Double-check yourself after installing points by taking a dwell reading to make sure you're within specs. And that brings us to the distributor cap. The distributor cap and rotor are simply a sequence switch which completes the secondary circuit to each of the spark plugs in the correct firing order. Corroded terminals or cracks are the most common kinds of distributor cap trouble. A visual inspection will usually disclose these conditions. However, carbon tracking and hairline cracks can be tricky conditions to spot. As a matter of routine inspection, try to wiggle the rotor with your fingers to make sure it fits tightly on the distributor shaft. A visual inspection is all that's needed to spot a pitted or burned rotor.
I know that spark plug cables come next in the secondary circuit, but I think it'll be easier to understand cable problems if we cover spark plugs first.
I'll buy that, Tech. The spark plug provides the gap across which the high voltage in the secondary circuit can discharge a spark to ignite the fuel-air mixture. The heat range of a spark plug depends largely on the length of the insulator tip. A spark plug with a long tip transfers heat to the cooling system slowly, so it's called a hot plug. A short tip gets rid of heat quickly, and it's a cold plug. Just be sure and use the recommended plug. Now, if you'll bear with me, I want to cover a rather technical fact about plugs and ignition voltage. An ignition system in good condition can produce more ignition energy than is actually needed to provide good ignition. This provides an extra margin of ignition output to ensure good performance. However, this extra electrical energy would cause radio interference and would shorten plug life if it weren't controlled or suppressed. That's why special radio-type ignition cables are used instead of cables with ordinary copper wire. The resistance built into these radio-type secondary ignition cables suppresses the extra energy that isn't needed for ignition. This reduces radio interference caused by the ignition system and increases plug life. Even so, it is normal for plug gap to increase about 1/1000th of an inch every 1,000 miles of driving. Plug electrodes also become rounded, and this, in combination with gap growth, increases the voltage required for good ignition. That's why plugs must be reconditioned or replaced periodically. Visual inspection of the spark plugs provides valuable clues to engine performance problems which may or may not be caused by the ignition system. The plug condition pictures in the service manual tell this story better than anything I could say.
Many perfectly good spark plugs are scrapped by mechanics who don't know how to use a compression-type tester. Here are a few facts about testers worth remembering. Under actual operating conditions, plug tip temperatures average about 1,000 degrees. And as was pointed out earlier, a spark jumps more easily from a hot electrode. In the plug tester, the electrode is at room temperature. In the engine, the air-fuel mixture provides a much better electrical conductor than the dry air found in a plug tester. In addition to this, under operating conditions of the engine, ignition usually occurs before the piston reaches top dead center, before peak pressure is reached. So the plug doesn't have to fire at maximum compression pressure. Here's how you should use a compression-type plug tester. Compare the maximum pressure at which a new plug will fire in the tester with the pressure required to fire a plug that has been cleaned, electrodes filed, and gapped. If the used plug will fire at a pressure that's as much as 30% less than a new plug, it will still provide good ignition.
If a spark plug fails to fire because of other ignition system problems, the condition may be temporarily helped by installing new plugs. However, this won't correct the basic trouble, and the customer will soon be back with the same old problem. Before I wind this up, I want to warn you about some spark plug cable problems. If they aren't properly routed, they'll be unnecessarily subjected to oil spillage, engine heat, and mechanical damage. In addition, current flow through the ignition cables sets up a magnetic field which is strong enough to cause crossfiring if the cables aren't properly routed. Here are 3 things that will minimize crossfiring, or as it's sometimes called, induction firing. Adjust spark plug gaps to specifications to reduce the voltage required to fire them. Route the cables properly and mount them in their brackets. Never tape or bind cables together in a bundle. It's particularly important to separate cables to cylinders that are adjacent to each other in the firing order. If you will just keep in mind what the ignition system is supposed to do and what happens when one of the ignition units doesn't do its job, you shouldn't have any trouble diagnosing and correcting ignition problems.
And to help you in the diagnosis department, there's a handy troubleshooting chart in the reference book. It lists all the more common ignition problems and tells you what to test or inspect. You'll also find everything we've talked about today and more in the reference book. And when you're servicing the ignition system, use the information and specifications in your service manuals. On today's engines, there's no room for guesswork. And since that uses up all the time for this session, I'll see you all next month.